Hello everybody, welcome to the Spitch webinar for partners. My name is Gary Williams. This is the first in a series of 3 webinars aimed at partners or potential partners of Spitch who are interested in developing and delivering speech-based applications. Now, whether that is in their own right or as enhancements to the existing solutions. Today, we're going to be talking about our development tools, principally Lingua Suite, Dialogue Composer, and Data Curator. These are our high-level development tools, which we use in-house, and we make available to our partners and clients where applicable, and this is a differentiator with some of our main competitors in the market, in that we are open in sharing this technology. The benefit of using these tools is being able to develop applications rapidly and deliver them quickly without any in-depth knowledge of speech technology or speech development software. In other words, Spitch have done all the heavy lifting in developing these tools so that you, the partner, can concentrate on solving the business needs of your clients and do that in the most quick and efficient manner. We're going to cover each tool in terms of the functions it has, how to use them, and what that will deliver. We will also demonstrate how to utilize that functionality, and our Chief Solutions Architect, Joe Novak, has created some great videos to illustrate what that looks like in each of the development tools. I'm also joined today by Vadim Shepanov, our Product Director, who will hopefully keep me on track, and at the end, both he and Joe will be happy to answer questions. I hope that you're going to get a lot out of today, and whether you're already well versed in the use of these tools or you're a newcomer to Spitch, I hope that you find today's session rewarding. Now, just a couple of words about myself. For those of you who don't know me, I've spent many years in speech recognition technology. In fact, more than half of my working life. And over those years, I've witnessed the use of speech recognition growing, first slowly, but more recently accelerating to become such a normal part of everyday life, both for professionals and consumers. Now, this puts us in a very exciting position today in that we are able to develop our own applications and solve the problems that our clients are facing now. So in saying that, I'd like to move on now to say a couple of words about Spitch, describe the tools themselves very briefly, as well as utilize them to solve problems. Spitch is both well established and well staffed, boasting a highly talented team. We're headquartered in Zurich, but we have offices also in Milan, London, Madrid, and Moscow. As part of our mission, we've undertaken to provide high-level and intuitive tools to our partners in such a way that our technology becomes synonymous with ease of use, rapid development, and delivery of business benefits into the market. We're able to deliver solutions in UK English, American English, German, Swiss, and uniquely Swiss German, French, Italian, and Russian. We can also easily implement new languages for our clients. Now, I'm just going to pause here and ask how you're experiencing the audio and visual quality so far. Please feel free to put into the chat box how it's going. Okay, so assuming everything's going, I'm going to tell you a little about how we're actually addressing the verticals with simple use cases. Now, because each vertical has its own business language, now that is to say, its own phrases and words that together enable some meaning, something we call semantics, we've developed tools that enable you to capture and use that within your solution. You can also develop the structures and business logic that can use that data in such areas as self-service, call routing, and voice biometrics, improving your customer experience, or CX, for your clients, as well as speech analytics and compliance monitoring, which help drive your clients' business intelligence and improve call center management. Add to this approach our ability to deliver our technology in different geographical languages, you can start to understand how we can easily address the needs of many verticals, and our list of use cases is growing all the time. The tools enable you to build bespoke solutions which are unique to your client's needs, on time and in budget. They will quickly get you through the stages of data collection, model training, integration, and go live, all in the fastest time possible. Now a little about the development tools themselves. The Spitch development tools enable you to create applications using the full spectrum of speech technologies. Furthermore, they have been designed so that you do not have to be a speech technologist or indeed a programmer to get the very best of the easy-to-use graphical user interfaces. Now, just speaking briefly about the individual tools, they comprise Lingware Suite, Data Curator, and Dialogue Composer. Lingware Suite is designed to fit into existing business workflows and scenarios. It helps to get to market quicker, rapidly deploy speech applications, and continually improve recognition for all business scenarios. Data Curator enables you to harness external data sources, for example, crowdsourcing, so that you can build and import your data corpuses, or should I say corpora, into the application and be running from day one. Dialogue Composer is Spitch's modern multi-channel platform for creating voice-driven self-services. Spitch uses natural language understanding, or NLU, artificial intelligence, with voice biometric identification and verification. This is accessed via a set of intuitive and friendly tools, and from that you can create effective communication applications for self-service systems. Now we come to our first audience opinion poll, if you don't mind answering this. And the first question we want to ask is a high-level speech technology development suite helpful to you? So what I'd like you to do is just look at the answers and choose the one that most matches your viewpoint. Now, back to the presentation, and I'm just going to start talking about Lingware Suite. It comprises three main areas: the GRXML Builder or Grammar XML Builder. Use this part to construct your speech recognition grammars. Now, the grammars are just the structured lists. They can be simple things like a list of names, or they could be more complex items such as date ranges or amounts of currency. The LVCSR SLT application builder, standing for Large Vocabulary Continuous Speech Recognition Spoken Language Technology. So it's a good job that we do abbreviate that. This is what helps you to build the backbone of your NLP application. Think of it as your database, if you like, of known words and phrases that are going to be in use in your solution. The idea is that this forms the corpus or dictionary that the system uses to learn what is meant when a speaker says something. This provides the framework on which will sit the business logic between the spoken language and the computer's understanding. The third element is the SSM, Complex Semantic and Sentiment Models Builder. SSM, standing for Statistical Semantic Modeling, uses SVM as classification and regression prediction tool. The understanding of the intent of a speaker and the sentiments that underlie it are modeled using statistical analysis. And again, Spitch does all the heavy lifting in the background, providing you, the developer, with a high-level, intuitive interface in which you tell the system what you want it to learn, the sentiments and intents you are seeking to pick up in your application. Now, this brings us to our first video clip in which Joe shows us how to access and configure the user profile in Lingware Suite.
In this clip, I'm going to describe the user profile section of the application. The user profile includes standard information about the user, covering their name, email, languages, organization, gender and age, as well as information about the account status, sign-up date, and current permissions level. There's an account limits section that describes user resource allocation and current usage statistics, as well as an API token generator. The token can be used by third-party applications to access application resources after you train or create them. The final section of the user profile includes a password reset panel. The user profile is updated dynamically in response to account and application events.
The presentation and talking now about GRXML Builder. We've kept things as simple as possible so that you can build your voice applications in 2 simple steps. First of all, you've got the GRXML voice application, which can transcribe and understand user-defined commands, phrase lists, and complex rules. And we have the Lingua Evaluator with an embedded graphical tool to allow you to evaluate, adjust, and fine-tune the grammars and complex voice applications. It's designed to be equally easy to use for both experienced developers and non-experts in speech technology. You can try out your grammars there and then on screen and see how well they work. And in this way, you can quickly create robust grammars that you can depend on. Now we're going to see another video clip in which you'll see how easy it is to create a simple grammar.
In this clip, I will demonstrate how easy it is to build a new limited vocabulary SimpleGram application using the SimpleGram application builder. The SimpleGram app builder can be found in the left-hand navigation pane in the Lingware section. First, I'll click on the link to open the builder. The application wizard has 2 main sections. The first section is the application basics section. Here, I can define the name, provide a short description, define the sharing context, and select the application language. We can ignore the ECMAScript element for now, as this only applies to GRXML grammars. I'll name the application provide a short description and select the language. And after filling the application basics section in, the second section of the wizard is the grammar editor itself. Here, we will define our simple grammar. In this case, we're going to create a short list of words and their corresponding output glosses, which are separated by a hash or pound character. We can use the special SPN token as a catch-all for out-of-grammar phrases. And once we've defined that, after we are finished defining our application and grammar, we can compile it on the fly by pushing the Compile App button. After a few moments, the compilation will complete, and we can open the evaluator to test it. Widgets incorporated. In this clip, I will demonstrate how easy it is to build a new GRXML application using the SimpleGram application builder. After filling in the application basics section, the second section of the wizard is the grammar editor itself. Here, we will define our GRXML grammar. In this case, we will create a grammar that recognizes a sequence, 2 letters followed by 3 digits. We've mapped the letters to standard NATO alphabet. After we're finished defining our application and grammar, we can compile it on the fly by pushing the Compile App button. After a few moments, the compilation will complete, and we can open the evaluator and test it. Alpha Bravo 123. That's it.
Now a few words about the component with that long name, the Large Vocabulary Continuous Speech Recognition Spoken Language Technology App Builder, the LVCSR SLT. So what you want to do now is you want to construct a file with all the words and phrases that are meaningful, that you want to identify, that give you the insight into a better understanding of that caller's sentiments. So this is really all about how you format your corpus of words and phrases so that it was ready for Lingware to combine into your speech application. So the next video shows you how to use a text corpus to train your speech application.
In this section, I will demonstrate how to create a text resource suitable for use in training a large vocabulary speech-to-text application. We can start this process by clicking on the Create or Update Resource button in the left-hand navigation pane under the Resources section. This will open the Resource Wizard. The Resources Wizard contains 2 sections. The first section is the Resource Basics. Here, we can configure the resource name, provide a short description, select a resource sharing context, and target resource language, and define the resource type. I'll do that now. I'll give our resource a name, a simple description, and assign a language and type. Here, we're going to upload a corpus type resource, so I'll select corpus as the option. The second section of the wizard is the resource upload section. Here, we can drag and drop or select our resource from the file picker. I have my corpus handy, so I'll drag and drop it. Once everything is configured, we can upload the resource. That's it. Now this resource will be available for use in training a new LVCSR or hybrid SSM application.
How to create the corpus. The next video clip shows you how to use that text and the SSM, the Statistical Semantic Model data, to train your hybrid speech application.
In this clip, I'll demonstrate how easy it is to create and train a new hybrid speech-to-text and SSM application using the LVCSR and SSM app builder and some pre-existing corpora. First, I'll click on the LVCSR and SSM app button in the left-hand navigation pane under the Lingware section. This will open the LVCSR Lingware application wizard. The LVCSR and SSM app wizard has just one section. This includes fields for the name, a short description, the application sharing context, the application language, and drop-downs for the target text resource and optional SSM resource. If you select an SSM resource, the wizard will train a hybrid speech-to-text and SSM application, which will return both transcriptions and classification results for each query that it receives. I'll give the application a name and a short description. I'll select the language and select both a text corpus and an SSM corpus so that we can train a hybrid app. Once the application is configured, we can click on the Compile App button to train the application. After a few moments, the application will finish training. We can then open the evaluator and provide the app with some example input. This application targets a cellular service provider. I'll ask it to block my SIM card. Please block my SIM card. The app returns both a transcription hypothesis and a topic classification hypothesis, as we expected. That's it.
Our second audience opinion poll. Now in this, we'd like to know if you've used LinguaSuite before, and if you have, what is the level of your experience? So please take a moment to look at the answers and choose the one that best matches your situation. Now we're going to get back to the development tools, and I'm going to talk about Dialog Composer. It's a browser-based visual developer tool which allows you to create new applications and scripts without having a deep knowledge of either programming languages or telecommunication systems. Only the logic flow that is desired in your client solution. The process is based on drag and drop and joining ready-made nodes representing certain processes. The tool gives you complete control over all calls in communication systems and IVR, including from third-party applications. You can track and control all interactions dynamically, add and remove nodes, branches, and modules. Standard protocols and common tools such as Java, REST API, and SDK are supported. At the same time, the developer is not required to have a detailed understanding of the specifics of the operation of communication systems, since the speech integration part is configured in the usual visual interface. A unified set of tools is used to handle various types of communication channels. Now, what are the benefits of Dialog Composer? Well, it can manage the traffic and get customers to the right place with NLU, intelligent call routing. You can intelligently route callers across distributed agent groups and contact center locations. Routing is based on client intention, business rules, and strategies designed to maximize efficiency, minimize the use of human resources, and improve customer satisfaction. Spitch can match customer needs and agent skills. Let customers ask a question to get a fast, human-like response from the AI self-service. Use natural language understanding and fine-tuned call flow to enable the routing of calls to the right place at once. Smarter routing improves first call resolution and customer satisfaction. Spitch can save agent time by gathering required information up front. Use the intelligent IVR to gather data that will help agents provide a faster and more accurate service. Spitch integrates with leading call center and ACD systems to help agents reduce call handling time while delivering a personalized experience. Now, the next sequence of videos that you're going to see shows you all the aspects of Dialog Composer that would enable you to create auto call routing and self-service applications.
The Dialog Composer provides a modular, Docker-based service which provides a wide range of flexible IVR-oriented features. At its core, the Dialog Composer is a visual programming tool designed to facilitate creation, editing, and evaluation of telephony-driven dialogue applications. It provides a user-friendly, web-based interface centered on a graph-based visualization of dialogue applications. Dialog applications are defined as directed graphs connecting nodes, where each individual node performs a specific function within the dialog feature space. The node types cover a broad feature space and a broad range of functionality. They include an announcement node for playback or dynamic TTS, an input node for integrating with speech-to-text and DTMF IVR applications, including the speech backend and custom user-built models, a record node for making recordings, a jump node to link nodes across branches in a flow or spans in a branch, a branch node for advanced decision making, a programmable HTTP call supporting JSON in and JSON out, an operations node for programming application variables, a module node for generating reusable functionality, a transfer node, a standard hangup node, a custom slot filling node, and a powerful code node which supports a built-in Python interpreter suitable for custom CRM integrations and highly flexible prototyping. The Composer features a live debugger which speeds up prototyping and test times and supports all modes and channels supported by the Composer itself. This includes text, voice, and integration with a number of messaging clients that's ever growing: Viber, Facebook, Telegram, website, and our own custom API. The system also supports self-documenting export to PDF, making it possible to leverage the real system not only to build real systems as well as prototypes, but to further use it as a discussion platform when planning requirements at the business case level. In addition to the editor, the Composer features a mapping section for mapping target numbers to applications, an audio files section for managing user-generated recordings, a voices section for managing TTS services, and a webhooks section for managing webhooks. Lastly, there's a sophisticated statistics and logging section where all information about call records can be stored and searched. The Composer features extensive documentation on all aspects of implementation, deployment, and use. And finally, it is backed by a robust REST API intended to support a wide variety of exploratory call analytics, which can help with discovery, understanding, and upsell potential. The first step in programming a new dialog application is configuring the start node. The start node defines default variables and settings for the entire application. This includes the node name, default timeouts for ASR applications, default exception behavior, default language, and TTS voices. This is the place where application-specific defaults may also be set. Note that most variables can be overridden in other parts of the call flow. The Start node contains 5 related tabs. The Config tab defines some basic information about the node itself. The Defaults tab allows the user to specify the default channel, TTS language, voice, and all timeouts related to the speech engine. The Exceptions tab allows the user to specify default behavior for each supported exception type, including the node where the flow should jump to when an exception is triggered. The Vars tab is where the user can set custom application-wide default variables. Finally, the System Vars tab defines the application-wide variables that are maintained by the Composer itself. Information in the System Vars tab is read-only throughout the call flow. The Announcement node provides a means to produce standalone announcements either via dynamic TTS or pre-recorded utterances. The Announcement node is composed of 2 tabs. The Config tab defines some basic information about the node, including its type and name. The Announcement tab provides a means to create and edit prompts for announcement. Here, it is possible to select the prompt type as well as define the TTS text. Dynamic variables can be retrieved from anywhere in the preceding call flow. The TTS voice can also be overridden on a per-prompt basis. If not overridden, it defaults to the application default. The input node type is used to process spoken user input and apply speech-to-text and semantic or sentiment analysis to user recordings. The processing result is returned to the application for use in other parts of the flow. If we open an input node, we can see that it is composed of several different tabs. The Config tab defines some basic information about the node, including its type and name. The Input tab allows the user to define the variable where the output will be stored, any prompts meant to accompany the input request, the TTS voice, the input type, the speech application, and webhook. The TTS voice will default to the application-wide default unless otherwise specified here. The input type can be set to ASR, DTMF, or mixed initiative. The Grammar Application dropdown will provide access to OpenDomain LVCSR and supported languages, as well as any custom application that you have trained in the Lingware Application Builder. The SSM Webhook tab provides a means to connect a simple webhook. This can be used to modify the output tags from the ASR and replace them with post-processing results based on alternative or complementary NLU models. The Timeouts tab provides a means to override the application default timeouts. This can be particularly useful in cases where you know the expected duration of a particular request. The Slots tab defines subvariables and contents that are expected to be returned by the speech application, while these results will be made available to the remainder of the call flow. The DTMF tab provides a means to configure DTMF input in cases where it's been selected as the primary input or part of a mixed initiative input node. The VAD tab provides a means to configure the VAD, the voice activity detector, for an individual input node. Finally, the Exceptions tab provides a means to override the default exceptions for the three main exceptions that are defined. This can allow you to direct an exception to a particular node that differs from the default specified in the start node. The Code node is a special node that provides access to a limited Python programming environment and the ability to run ephemeral pieces of arbitrary Python code as part of a dialog application. As with all nodes in the composer, this one includes several tabs. The Config tab defines some basic information about the node, including its type and name. The Params tab defines the node level variable where results will be stored for use, and the timeout parameter, which determines how long the code snippet should be allowed to run before it triggers an exception. The Code tab provides a custom Python editor where the user can program an arbitrary snippet. See the documentation for information about library and module availability. The Input Params tab provides a means to expose copies of the call flow variables to the snippet for processing. The Test Params tab provides a means to create a testing environment for trial execution, while the Test tab provides a means to actually execute it. The Slots tab provides a means to define what variables are returned by the code node for later use in a dialog application. Finally, the Exceptions tab provides a means to customize exceptions for this particular node. The Composer provides a useful live debug mode, which includes a handset simulator capable of simulating interactions with a deployed dial plan. In order to open the debugger, simply click the cell phone icon in the top right menu bar. Note that opening the debugger sets the editor into read-only mode, and you cannot modify the flow while you are debugging it. The debug simulator supports all channels currently supported by the composer, including voice via SIP client or PSTN. Here, we will interact with it in voice mode via the voice channel in order to illustrate the full interaction. In order to start it, enter the number you will be dialing in from and then call. The simulator will walk through the flow and note the process, and any log or error messages along the way. It will be triggered automatically by our incoming call. This feature is very useful for quick turnaround times and updates. I'll make a call to our toy JiraBot now.
Hello, welcome to the ticket system. Please state your company name.
Speech AG.
Please state your contract ID.
Alpha Bravo 123.
Please describe your issue so we can create a ticket.
I have a very simple issue and I'd like to talk to you about it when you have some time.
New ticket created for Speech AG. Have a great day.
Finally, after the call is made, you can review the logs in the statistics page.
So that concludes Dialog Composer, and now we move to the third tool, something called Data Curator. Now this is a comprehensive platform for managing data that allows computers to learn without explicit programming. It helps your business to make intellectual ML and AI virtual assistants that understand your customer's intent at once. With this tool, you can harness live streams of data, manage the users and roles, configure payment methods, pay those users, test and queue data directly into Dialog Composer. So key to preparation in getting that data, first of all, you want to harness the external data, you want to process it, you want to provide all the necessary, what you might think of as preschool rules, just like a child going to school, so that the system can start learning before implementation. You can also synthesize data if no external data sources are available. So through this, you provide all those rules that the system can utilize right away so that the application can, as we call it, hit the ground running. So in the next video clip, Joe shows you a general overview, aspects of user management, queuing data, and the annotation pane.
The Data Curator provides a means to collect, collate, annotate, and audit text and audio resources. The Data Curator can be integrated directly with the Dialog Composer, making it possible to directly enqueue new recordings as they are created in active Dialog applications. The Curator is based on a queuing concept which facilitates continuous ingestion and processing of new resources. It provides an overview dashboard, a data annotation dashboard, illustrating active queues, advanced search functionality, and management functions suitable for managing data queues, users, languages, organizations, intents, entities, and agreements. There are also facilities for JSON and S3 imports, integration with Google Drive and Dropbox, and finally, integration support for PayPal. The annotation facilities themselves support annotation of audio files, NLU annotation of text files, and hybrid two-stage annotation for complex applications. Finally, the portal is backed by a fully featured REST API which supports scripting of almost any action the system itself supports. A data queue is the central element of the annotation workflow. Each queue is a dynamic entity which can be configured to continuously ingest more resources. making them available for annotation and audit only to those users with the appropriate qualifications. The top-level active queue view illustrates the number of resources, words annotated and audited, and the percentage figures indicating completion progress. Clicking on a queue opens up the detailed resource view. This view supports search filters, status filters, and region filters, which are able to provide the annotator or auditor the ability to selectively review the process at different stages. Expanding an individual resource brings up a summary and a list of possible actions. We can choose to assign, unassign, or visit a particular state of the resource annotation flow. Configuring a queue is quite simple. If we open up the Queues tab from the left-hand navigation pane, this will bring up the list of available queues. If we select the queue, this will bring up the configuration pane, which allows us to set a name, the status, the target language, a short description, and the annotation mode. The annotation mode may be set to audio or NLU, or both. The configuration pane further supports queue tags and allows the manager to set custom speech events for annotation. Finally, it is possible to directly assign annotators, auditors, and payers, attach specific intents to the case of a hybrid or NLU-based queue, and finally, assign an organization, an audit target, and a price multiplier that indicates the difficulty of the target data. The annotation pane is the place where all actual annotation work is carried out for each resource. The annotation pane contains several components. At the top of the page is a summary of the resource and the queue it is related to. Documentation is available summarizing the annotation process and guidelines. Below this, in the main panel, is a visualization of the recording as a waveform. Playback and zoom tools, as well as tools suitable for segmenting the waveform, are available underneath it. There are subpanes which provide toggles for the annotator to classify the speech and speaker found in the recording. The editor subpane includes buttons and shortcuts for frequent or important speech events, and the editor itself provides the means to enter the actual transcription. If auditing is enabled, the delta between the auditor and the annotator can be seen in the complementary panes. The annotation queue may be integrated with an ASR backend to supplement the process with automatic results, and also includes sections for annotator and auditor comments. We can save the transcription component of the annotation when we are finished, and this will take us to the NLU component, where we can annotate the text with any relevant intents or entities in the case of a hybrid queue.
To our third and final audience poll, in which we'd like to understand commas. In other words, we always want to continue to develop these tools and refine them. So have a look at the answers, and if you see something that closely matches, what you think you need in addition to what you've seen, then just highlight that answer rather, if you wouldn't mind. Now this brings us to the last part, which is an important part actually. It's where we touch base with reality and take questions from our audience. And I'm joined, as I said earlier, by Vadim Shepanov and Joe Novak. And so we will field some of those questions. Now I've got a great one from Tom here. And Tom wonders whether Dialog Composer can run with an existing PBX, or does he need to replace that PBX with something else? And I'm going to put that to Joe, if you don't mind.
I'll take that question, Billy. The Dialog Composer has been built with a modular architecture in mind, and we actually provide integration with a variety of different PBXs via an adapter-based approach. So by default, we ship it with an adapter that's configured to work with the open source PBX FreeSwitch. And we also provide a VXML-based adapter that can be used together with Avaya, Cisco, and Genesis PBXs. We have also in the pipeline another open source adapter in the works for the Asterisk PBX. So in theory, yes, but and we can also develop additional adapters if there are customer needs related to different PBXs that we aren't currently supported or can't be directly supported already via the VXML adapter.
Great question and great answer. Stay on the line, Joe, because we've got some crackers along.
All right.
So Alex is asking, can he integrate a workflow he developed on Dialog Composer with the CRM or a back-end system?
Mm-hmm. That's a great question. And actually we have right now 2 different ways to support that concept. So I think we saw in the video both the HTTP node and the code node, and these provide 2 different means to integrate in a pretty flexible means with arbitrary backend systems. So the HTTP node implies that you have some kind of REST-based, fairly well-structured API that you can integrate with. And if you have that, you can simply configure an HTTP node and send the data that you want to your backend via the Dialog Composer. Or if you have something that requires a bit more flexibility, you can use the code node, where you can actually pretty much whatever you want within reason and within the constraints in terms of what modules we permit you to import into the Python interpreter there.
One more question, Joe, if you don't mind, and this is from Laurent, and wants to know, is a Spitch application exportable? In other words, can it run locally and offline, Internet of Things, or is it cloud only?
So there are a couple different levels to that question. I think that first there's this concept of what you can export. So it's possible to export all of the metadata related to all of these applications, for one thing. So you can transfer them from one installation to another, export them, import them. And yes, it's also possible to export the entire application framework. So we've designed it with this idea in mind from the beginning, that you should be able to use and develop and prototype everything in the cloud for as long as it's appropriate, and then also have the ability to seamlessly transition any of those applications to an on-site location, so that you can do it within your company VPN, or you can do it on a single machine. Obviously, the one constraint for, say, the Dialog Composer is that you would still need to have some kind of networked ability to input data to the system. And that might be from a kiosk if it's all installed on a single machine. But other than that, yes, it should be possible to do that for most cases.
So, Joe, I'm going to rest you now, because the next question I'm going to direct to Vadim, if he doesn't mind. And this has come from Ilya, and Ilya wants to know if the Which technology records the voice, or does the customer have to use some external recording system and then after that upload it to Spitch? So Vadim, if you wouldn't mind answering that one.
Thanks, Elias. Generally speaking, speech products can record, and speech products are recording customer voice as a log of what we're doing with customer speech and customer calls. Yeah. But we also, in our speech analytic products, in our speech analytic dashboard, we can use recordings from third-party systems if those systems allow us to upload on the system. So the answer is both positive. So we can record ourselves, or we can use recordings from other systems, depending on use case and depending on existing of this kind of system. Yeah. So thank you.
Great question. Okay, any other questions that we've got in today, we will answer offline if that's okay, because we need to draw things to a close. Just a few more things that I want to ask you. Next steps, please go to our landing page, which you'll find is a refreshed landing page, and try the development tools yourself or download additional information. Also, please register for the next webinars. We'd love to see you there. And please do connect to your local Spitch team, and you'll find the details on our website. So there's nothing really else for me to say other than, from myself and the whole team, a really big thank you for attending today, and we hope to see you again at the next webinar.